additional topics in math, circles. This chapter basically deals with some fundamental geometrical shapes, geometrical objects, whatever you say, just like circle. And we are just going to talk about circle today. And we are also going to talk about some other things like related with the circle, like radius and diameter. We're also going to talk about area and circumference, 360 degree in a circle, inscribed angle, and arc length, sector area, and then do some practice problems. And we are also going to talk about radians. Basically, radian is a very, very important unit. I already told you that radian is one of the units for measuring the angle. And then we are also going to do some real problems, which are some real aesthetic problems, real look-like problems. Okay, so talking about the circle, we need to know about some very fundamental and very basic units or very basic parameters, just like the radius, the area, the circumference, and the angle, And what does that mean, basically? What does that mean? We already know that a circle is just like a geometrical shape, which looks like this. It has a center. This is called the center. And the distance from the center, this is basically the center. And the distance from the center to this line, it is called the radius. We already know that. We all know that. So for a circle, we have a radius, and we also have a unit, a different parameter, which is called diameter. You can call that a parameter for a circle. So the parameters for a circle, the geometrical shape circle, we have different parameters, just like radius. We have diameter, we have area, we have circumference, and we have arc length, and we have angle and other, etc., and other things. Okay, so radius and diameter are related, just like this is the radius, and the diameter is nothing but the twice of a radius of a circle, Basically, diameter is just the thing which we are measuring from the center to the circumference, or the circle. But the diameter is basically the distance from one point to the another point, from one point to the another point, crossing, going through the center. This is basically the center. And to measure the diameter, we must go crossing the center point for a circle. So it means that this cannot be the diameter. Okay, for this given circle, this is the center, but this cannot be the diameter. I mean, this curly braces indicated distance, this line. Okay, this line cannot be the diameter. It must be like this. Okay, so this is pretty basic thing. I think we all can do the example. What is the radius and diameter in the circle drawn below? We all know that the radius is 5 and the diameter is 10. Okay, so the next topic is area and circumference. the area and circumference, the area and circumference is basically two different parameters, two different quantities or parameters, whatever you just want to name it. You can do it in your own way. But the area of a circle is is the area that is enclosed by a circle. The area of a circle is the area enclosed by a circle. And till now, what we have talked about the geometrical shapes, like rectangle, square, parallelogram, trapezoid, and other shapes like polygon, pentagon, heptagon, hexagon, octagon, nonagon, whatever it is. They all are two-dimensional. And for a two-dimensional geometrical object, for a two-dimensional geometrical shape, the only thing we have that is basically area. Yes, we have other things like we have length, we have width, we have a circumference for a circle, we have radius, we have a diameter. These all are just some quantities regarding a very very specific geometrical shape. Because you cannot say what is the radius, what is the radius for a rectangle. For a rectangle, we don't have a radius. It is not it is undefined because we don't have any kind of radius. But for a circle, we have a parameter or a quantity which is called radius, and we have diameter. For the rectangle, we have length and we have width. For a rectangle, we have length and we have width. So just like this, for a circle, we also have a parameter. We also have a quantity which is called the circumference, and the circumference is the perimeter. The circumference is a perimeter. The perimeter, I'm using the word perimeter as an analogy. And I have already told you what is the meaning of analogy, because an analogy is nothing but just some relationship between two different situations. For an example, we have a situation A and we have a situation B. And for a situation A, for an example, we have a parameter called small a. And for a situation B, capital B, we have a parameter called small b. So if situation A and B are related with each other, then we can also tell that this quantity small a and this quantity small b are related with each other and analogous to each other. So that's why from that concept, I'm using the word perimeter because we are not allowed to use the word perimeter for a circle. We are allowed to use the word perimeter for a rectangle, for a square, or for a trapezoid, or for a parallelogram. We can use that. But for a circle, we cannot use the word perimeter. Instead of that word, we need to use the word circumference. But both are basically same. Circumference means basically the length of this thing, whatever it is. I mean, I'm just trying to make you understand that whatever you just name it, you can just, if it is easier for you to call it perimeter, then you can just call it perimeter. But in the formal language, in the academic language, or in the mathematical language, you cannot call this perimeter. You must need to be called as the circumference. And the circumference is twice pi r, and the area of a circle is pi r square. These are very important equations or law or whatever it is, formula, you just name it. But the circumference and the area are two different quantities or parameters. For this given circle, the area would be pi r squared. So it means that pi, and for this circle, the radius is r equals 5, because the diameter is the twice of the radius, or the radius is the half of a diameter, whatever you say. Just like a mathematical relationship, if you want to develop, just like d equals 2r, then for this given circle, d equals twice r equals 10. So using the laws of equation, we can write 10 divided by 2, that is 5. That is 5. The radius is 5. So that is 5 squared. That is 25 pi. This is the area. This is the area of this given circle. Area of this given circle. But the circumference, circumference would be the perimeter of this geometrical object. Just like we had started walking along this curvilinear line, and after that we have finished here at this point again. This is the perimeter, and we call it circumference. And for this given circle, the circumference would be twice pi r. 2 pi r is equals 5. That is 10 pi units. Okay, this is it. It's quite simple. We all know about that. Mention that if it is fine to use formula circumference equals pi times diameter, if you would prefer. Okay, fine. We don't have any issues with that. So we already come to know about the area and circumference. We have went through the area. We have come through the circumference, and we have come to know about the relationship between diameter and radius. So I'm just trying to make you understand again that the diameter and the radius can affect the equations for circle. For an example, in terms of radius, if you want to find the area of a circle, that will be pi r squared, and the circumference C would be twice pi r. But in terms of the diameter, the equation or the law or the formula for a circle would be A equals pi d by 2 whole squared. It means that it would be 1 by 4 pi d squared, right? And the C would be pi d. Please don't mess it up. Okay? Because we can write the equations or the laws or the formula in terms of radius and in terms of diameter. Do you get it?
Yeah.
Okay, what is the area and the circumference? What is the area and the circumference of a circle with radius of 5 inches? I don't think I need to solve this equation or solve this math problem. Okay, so now let's move to 360 degree in a circle. So 360 degree in a circle, it means that the angle that is covered for a given circle, whatever, not for just a given circle, any circle. The angle 360 degree for a circle. It means that for a complete rotation, for a full rotation of a given circle, the angle that is produced is 360 degree. This is the full rotation for a circle, and the angle that is created, this is basically 360 degree. And I have already told you that you can measure the angle in different units. And to measure the angle, we have different units, like we have degree, we have radians, and we have some other units too. But whatever it is, for the concurrent knowledge till now, we have contemporary, you can say that 360 degree is the complete angle or the full rotation angle that is produced by a circle. Okay, so a circle can be divided. Focus on the example. This is a circle can be divided into how many right angles? A circle can be divided into how many right angles? So it means that they're just asking that how many right angles we can produce from a complete rotation of a circle. It means that 360 degree is the complete rotation angle, the angle for a circle full rotation, and how many right angles we can produce. 360 degree divided by 90 degree. This is going to be the answer, and that is four right angles. Four right angles. Okay, four right angles. That is very simple. And if you want to visualize that, then you can just visualize it like this way. Okay, we are just dividing the angle into four different parts. This is, okay, this is part one, this is part two, this is part three, and this is part four. This is part four. So this is how you can just think about the problem. Okay, so now let's talk about inscribed angle. Do you have any question? Do you have any question?
No, not yet.
Okay, okay, all right, okay, all right. So now we are going to talk about, basically, we're going to talk about the inscribed angle. What is an inscribed angle? What is an inscribed angle? The inscribed angle is, this is a less common concept related to degree measure that is good to understand just in case a problem about it comes up. So it means that, it means whatever it means, basically, they're just talking something about else, but it's our main primary goal to know about the definition or to understand the topic. What actually inscribed angle mean? In the graph above, 2x corresponds to a central angle and x corresponds to an inscribed angle. When the inscribed angle and the central angle have the same arc, the central angle is twice the measure of the inscribed angle. I'm reading it again. In the graph above, this figure, 2x
Mm.
corresponds to a central angle. 2x corresponds to a central angle. Okay. 2x corresponds to a central angle. This is basically our central angle. This is basically our central angle. This is our central angle. And x corresponds to an inscribed angle. Corresponds to an inscribed angle. This is our inscribed angle. So this is what we are interested about, because our topic name is inscribed angle. Our topic name is inscribed angle. So we are going to talk about the inscribed angle. What is inscribed angle? This is an inscribed angle. This is an inscribed angle. So when the inscribed angle and the central angle have the same arc, the central angle is twice the measure of the inscribed angle. This is basically kind of a theorem. This is basically a kind of theorem. I'm just underlining the theorem portion in the green underline. I'm underlining it with green lines. This is kind of a theorem. Okay, this is kind of a theorem. But the thing is, the inscribed angle is basically this x, and the central angle is 2x. And it is basically consistent in such situation. It is consistent, it is generated, or it is produced, or it is created in such situation when basically we have a circle, and then we have a given arc. For an example, this is a given arc. Okay, we can talk about the arc in a different sometime later, but primarily just try to understand and name it just like this is an arc, the violet portion. Okay, do you understand this, what I'm talking
Yeah,
about?
yeah.
This arc, and this is our central angle. The central angle is drawn in the green portion. Okay, this is our central angle. This is our central angle, and the thing is, the inscribed angle defined like can be defined like this. Can be defined like this, like the red angle. The red angle. This is our red angle. Okay, this is the red angle. So the red angle is the inscribed angle. The red angle is the inscribed angle, and why you are calling that inscribed angle? We are just calling it inscribed angle because it is inscribed inside the circle. Inscribed inside the circle by a given arc. This is our given arc. This is our given arc. This arc is our given arc. Okay. For an example, we are calling this as a given arc because for a given situation, for a given situation, we have basically a given arc. So the given arc is producing a central angle, which is the green angle, and the red angle is the inscribed angle. The red angle is the inscribed angle, and the green angle, the green angle, the green angle is the central angle, the central angle. Okay, so this is what we are just talking about, the inscribed angle and the central angle, and they're just telling a theorem that is central angle, the central angle and the inscribed angle, which is produced from the same arc, from the same arc. There is a relationship. There is a relationship. There is a mathematical relationship. The mathematical relationship is telling that. The mathematical relationship is telling that. The mathematical relationship is telling that the central angle, central angle, central angle is equals to twice of the inscribed angle. Inscribed angle. This is our theorem. This is our theorem. The central angle is equal to twice of the inscribed angle. This is our theorem, okay? This is our theorem. This is our theorem. So this is the theorem that they are talking about. So we have some problems. Maybe we have some problems. We are going to face some problems for this given theorem. Maybe we are going to face some problems regarding using this theorem carefully. Okay, now let's talk about this example, which is in the circle graphed below. With a central angle of 80 degrees, what is the measure of x? Man, what I'm just talking about. The same thing is happening, because I've just told you they're just gonna give us a problem related with this theorem. So that is it. That is it. Just use this equation, use this formula. Okay, this is a formula. This is a formula. I'm just using this epsilon notation for my formula because I'm using it for maybe for 8 or 9 years. Maybe I'm using this notation from class 5, grade 5, whatever. And I use it to denote a formula, this epsilon notation, and then a circle around it. Okay, so 80 degree is equals to twice of x. Am I correct?
Yeah.
Because the central angle, this is the central angle, the central angle, the green angle here, the central angle, the green angle here is the twice of the inscribed angle, and they have the same arc, and that's why we are allowed to use the theorem, because they're sharing the same arc. They're sharing the same arc. If they were not sharing the same arc, then we couldn't be able to use this theorem. And for the blazings of sharing the same arc, we are allowed to use this theorem. We're allowed to use this theorem because this theorem is only valid in such situation where they're sharing the same arc, and then we can say the central angle is equal to the twice of the inscribed angle. So from that theorem, we can write like 80 degree equals to twice of x, so x is equals to 40 degree. Do you understand it?
Yeah.
It's just like drinking water. Okay, anyway. So we have some practice problems. Let's look at the practice problem, what they're talking about. Okay. The problem number 1, if the radius of a circle is x units, what will be the diameter of the circle in terms of x? If the radius of a circle is x units, what will be the diameter of the circle in terms of x? X divided by 2, because I'm sorry, so the diameter will be 2x, twice x, right?
Yeah. Yeah.
Twice x. What is the area of a circle with a radius of 10 inches? What is the area of a circle with radius of 10 inches? We can use the formula. A equals pi r squared, right? We can use the formula pi r squared. Pi r squared, A equals pi r squared. What is the circumference of a circle with a diameter of 4 inches? We can also do that by using the formula. If a circular pie is to be divided into 12 equal pieces, what will be the measure of the angle formed at the central tip of each piece of pie after the pieces are cut? If a circular pie is to be divided into 12 equal pieces, If a circular pie is to be divided into 12 equal pieces, what will be the measure? What will be the measure of the angle formed at the central tip of each piece of pie after the pieces are cut? Do you understand what they're trying to mean? So it means that basically, for just like this is a pie. This is pi. This is Mr. Pi. This is Mr. Pi, and we are cutting Mr. Pi into 12 equal pieces, into 12 equal pieces, into 12 equal pieces, and then the pieces maybe look like this. Maybe we have some 12 pieces. Just consider we have 12 pieces. So what will be the angle? What will be the angle for a particular, for each piece of pie that is cut? So what do we need to do? We just need to divide 360 degree by 12, because we are creating the angle here, for a pie. Consider this angle for a, just like we have 12 same type of piece of pie, 12 same size piece of pie. Okay, so this is one of them. One of the 12 same size pieces of pie. So what is the angle here? I'm mentioning this angle, this this green shaded angle, here. So what do you need to do? You just need to divide 360 degrees divided by 12. Am I correct?
Yeah.
Okay, that is it. Yeah. Okay, so now problem number 5. What is the measure of the central angle of A of the sector drawn at the figure below? I'm not going to solve this problem. This is basically the theorem that we have just talked about just a few minutes earlier, right?
Yeah.
The inscribed angle and the central angle theorem. Okay, fine. Now let's look at the arc length. We already know what is the arc length. The arc length is nothing but just like a curvilinear line. We have two different type of line. In terms of geometry. We have the linear line. Sounds might awkward. And we have a curvilinear line. We have a curvilinear line. So the curvilinear line is just an arc. This is our arc. This is just an arc. This can also be an arc. This can also be an arc. This curvilinear line. This green colored curvilinear line. These are called arc. And maybe we can just divide a circle into so many arcs as we want to do. And an arc will definitely create an angle regarding the center. Because if you are just connecting the two endpoints for an arc, consider this is an endpoint and this is an endpoint. And if we are connecting these two endpoints with the center, then we get an angle. This is our angle, and this is the angle that is created by an arc. Do you understand?
Yeah.
Okay, that's pretty simple. And we have a formula here. We have a formula that is saying that part divided by whole equals angle divided by 360 degree is equals to the length of arc and divided by the circumference. Maybe we're going to solve some mathematical problems by using this formula. Part divided by the whole equals angle divided by 360 degree, and it is equal to the length of arc divided by circumference. It's a very useful formula. For an example, let's look at this problem. In a circle of radius 3 with an arc 60 degree, what is the length of the arc? In a circle of radius 3 with an arc 60 degree, what is the length of the arc? You just need to use this formula. You just need to use this formula. You just need to use this formula, and then you just need to put the values. Just plug in and solve. Plug in and solve. Plug in and solve. The the circle has the radius 3, okay? The circle has the radius 3 with an arc 60 degree. With an arc 60 degree, what is the length of the arc? We are called we are called to find the length of the arc. And to find the length of the arc, we just need to find out what is the part divided by the whole. To part divided by the whole, you can just solve this by the given formula. It's quite simple. And then you just need to do the proportion. For an example, they're just doing like this. You can also solve like this, or you can just use a different formula. I'm not interested to teach you that formula because maybe remembering that formula maybe might be hectic for you. But we have some pretty shortcut formula. We have some pretty shortcut formula to find the arc length. Okay, we have a pretty shortcut formula to find the arc length. Rather than you should use this formula. Use this formula as they are trying to tell you. Maybe we can teach you some other time about the shortcut formula. Okay, so now this sector area. Okay, this sector area is nothing but the area that is created by an arc. The yellow zoned area. This is the sector area. The area of the sector. Okay. Do you understand? Hello.
Yes.
Do you have any question?
No, I think I get it. So the sector is the whole thing inside.
Yeah, the sector will be the inside. Definitely, the sector is definitely inside of the circle. Yeah, that's pretty. That's obviously it will be located in the inside of the circle. You can just use this formula to find or to do any kind of problems. Part divided by whole equals to angle divided by 360 degree is equals to area of sector divided by the area of circle. So in a circle with a radius of 3 and a sector of 60 degree, what is the area of the sector? In a circle with a radius of 3 and a sector of 60 degree, what is the area of the sector? We are we are asked to find the area of the sector. Okay, then tell me, how can you solve this problem? Tell me.
360 divided by 360.
And then
I don't know.
try it. At least you should try.
60 divided by 360, and then
You're telling 60 degree divided by 360 degree, and then for an example, this is the area of sector. We are just denoting it with AS.
yeah,
And
that,
what
and
is the
then
circle of the area? Divided by
the sort of the area of the
pi,
circle.
pi r square. Yeah, then you just need to find the AS, okay? And then if you're just doing it, this is basically 1 by 6, and this is gonna be 9 pi square, right? And you just cross multiply and then divide. You get AS equals 3 by 2 pi. 3 by 2 pi. This is quite simple.
Wait,
Right?
how is it 3 by 2?
3 by 2 pi, basically. 3 by 2 pi.
Oh, okay.
I'm sorry. I'm
Oh,
just writing here 9 pi square. Sorry.
yeah,
There should be no pi. There should be no pi square. I'm
yeah,
sorry. This is
yeah,
basically 9 pi. 9 pi.
yeah, okay.
3 by 2 pi. Do you understand?
Yeah.
They're just using a formula. They're just using this simple formula. We have just this simple formula, part divided by whole. Actually, we don't need any part divided by whole here because we are not given any kind of part and whole scenario, because we really don't have any part and whole scenario here. What we basically have here we don't have any part and whole scenario. What we basically have here is there is basically the area of sector, area of sector, area of sector, area of circle, area of circle. The area of circle is not given directly, but absurdly or abstractly, the radius, the circle, the area of the circle is given because we have the radius, because we already know about the radius. We already know about the radius of the circle. So that's so we can definitely find out the area of the circle. So we know about the area of the circle. We already know about the area of the circle, and we just need to find it. Okay, we just need to find it, the area of the sector, area of the sector. Then just use this portion of this formula, this portion of this formula, the yellow highlighted area, the yellow highlighted portion of this formula. You just need to apply it, and then you just need to plug in the values. Do you get it?
Yeah.
You don't need to write this all of these lines. You just don't need to write all of these lines because these are extra lines. Okay, these are some extra lines. Some extra lines. Make it short. Make it short as soon as possible. Make it short as far as possible. Make it short as much as you can. As much as you can. That will save your time. Okay. So what is the length? We have some practice problems here. What is the length of a 45-degree arc in a circle that has a radius of 5 inches? This is this formula. This is this formula. We have this formula. You just need to apply this formula.
Yeah.
And then what is the area of a 30-degree arc in a circle with a radius of 4 inches? The same formula. A circular prism. This is basically gonna be our this application of sector area. Okay, these are some child games, and we will do some other extra topics. That is for your homework. That is for your homework. The homework. I'm in these yellow marked, yellow highlighted the question. This is for your homework. Please don't skip any kind of homework, and not sorry.
Just that one? Or...
Every single problem is your homework. Every single problem is your homework. But I'm just telling you, I'm just putting the emphasis that you must not skip any kind of practice problem. Any kind of practice problem and every single real problem. Read every single problem. Think about every single problem. Don't use pen and paper. Rather than use your brain. Think it by your imagination. Solve the problem with your imagination. Solve it inside your head. Solve it inside your head. And if you cannot solve a problem, inside your head just by your imagination, then write it. Write it on a paper. Then use pen and paper. Because otherwise you won't be able to solve so many problems. Because writing every single problem will take a lot of time. It will consume a lot of time. And to resist the huge consumption of time, you just need to do inside your brain, because as much as you are utilizing your brain, that will save your time and it will make your brain more powerful. Okay, because writing won't help you that much, maybe in some cases, but thinking about the problem will give you high efficiency. And most importantly, please try to solve the math problems in a very efficient way. Maybe they're just doing this kind of a stuff, the the green and yellow marked area is some existenceability. Okay, these are some extra. Maybe you can just solve this problem number 3, in a pretty shortcut way and do it. Try it. Okay, try it. Don't think about some every single steps that you need to do. Maybe you just need to apply this whole 2 lines just in one simple formula. Do you understand what I'm talking about?
Yeah. Yeah.
Okay. The circle formula, because the circle formula here we're discussing, that is basically related with the coordinate geometry. As a matter of fact, that this chapter basically deals with the circle. And the matter of fact is, in this chapter, they are talking about the measurement related with circle, and then they're also talking about the coordinate geometrical concept of circle, concept of circle, excuse me. So what does that mean? It means that we have already covered the radius and diameter. We have talked about radius, we have talked about diameter, we have told you about some equations, some formula, some laws, whatever you might want to name it. Then we have talked about area and circumference, and then we have talked about 360 degree in a circle, and then we have talked about inscribed angle. These are basically the concepts related to it, geometrical measurement. And then we have talked about arc length, and then we have talked about sector area. Then we have talked about some existensibility problems, not to make a given problem too long, not to make a math problem too long. And now we are focusing on the coordinate geometry concept, on the coordinate geometrical concept of circle, just like what we have dealt with the straight lines and slope. Do you remember lines and slope we have talked about? Because
Yeah.
in the lines and slope, we talked about y equals mx plus c. You can also write this c as b. You can also write this equation as b, y equals mx plus b, You can also write an equation called the ax plus by plus c equals 0. Ax plus by plus c equals 0. So these are the equations of a straight line, and in a bigger sense, and in the rigorous mathematical text, we divide or we talk about this type of topics, or we deal about in this type of topics in a section of mathematics, what we call analytical geometry. So this is the part of the circle. For this chapter. In this topic, we are going to talk about the analytical geometrical concept of circle. So how does that look like? It looks like you just need to plot a circle. You just need to plot this circle. Just consider this green shaded circle, in a given graph paper. This graph paper, you just need to plot it in a graph paper. So how do you do that? You just need to use the concepts of analytical geometry. And how do you use the concepts of analytical geometry? You must need to apply the algebraic equations for circle. You just need to apply the algebraic equations for circle on a geometrical plane. So this graph paper is our geometrical plane. Do you understanding what I'm talking about? Do you understand?
Yeah.
This is our geometrical plane. This graph paper, this vertical lines, this horizontal line, all of this thing is our graph paper. Just consider it as a graph paper. And then we just need to draw a circle. And how do you do it? Definitely we need some equation, just like we needed in the straight lines case. We needed y equals mx plus b. We needed x plus by plus c equals 0. In the case of a straight line. And so that's why we also need this same type of equation, not this exact same type of equation, but primarily that will look like quite similar. That type of equation, like the algebraic equation for the circle. So that is it. This is going to be our desired equation. This is going to be our desired equation. So this is our equation, and we have some other equations for circle too. But primarily we are going to talk about this very equation, which is x minus h whole squared plus y minus k whole squared equals r squared. This is our desired equation. This is our desired equation for this particular situation, because I'm saying this particular situation. Why? Because we have also different equations. We have also different equations. We have so many equations. We have so many equations for circle. We have so many equations. We have so many equations. We have so many equations for circle. For circle. But we are only interested. We are only interested in this form. Not so many equations. I should say so many forms. So many forms. So many forms of equations, so many forms of equations for a circle. And x minus h whole squared plus y minus k whole squared equals r squared is one of the forms of equation of circle. Do you understand? Do you
Yeah,
understand?
kind of. Yeah.
So what is basically a form of an equation? What is basically a form of an equation?
Sorry?
What is a form of an equation?
The HK one.
HK1 is not a form of equation. I want an example. What do you understand basically with a form of an equation?
Like the formula
Okay, like the formula, then what formula?
for a circle, that would be one of them would be the 2 pi r squared or something like that.
Okay, but that's a formula. But what about the form of equation for a straight line? What does the form mean? What does the form mean? What does the equation for a straight line?
Sorry, I don't really get what you're saying.
What does it mean? What does it mean by the phrase form of equation for a straight line? Form of equation of a straight line. What does that mean? This phrase, this very phrase, form of equation of a straight line. What does that mean?
Mm, I don't know.
Okay, a form of equation means a form of equation. It's as
Yeah,
simple as
yeah.
that. A form of equation means a form of equation. Okay, a form of equation means a form of equation. It's as simple as that. Form of equation means a form of equation.
Wait,
A
can you
form.
scroll up a bit to the graph? That one? So what is it like the 3 to what does that mean? Like in the graph?
Are you just talking about this thing?
Yeah, it's kind of confusing. No, the
Okay,
one under the the graph with the circle. Yeah.
this 3 and 2.
Yeah, I'm not getting that.
Okay, we will talk about that. We're going to talk about that. But primarily, the form of equation, what I'm talking about, that is basically the form of equation means the form of equation. A form of equation means, as I've already told you, that a straight line can be defined, a straight line can be expressed, and a straight line can be expressed by the algebraic equation y equals x plus b, x plus by plus c equals 0, x plus by plus c equals 0. We can express the straight line. We can express the straight line by this equation. And
Mhm.
this is one of the form of equation for a straight line. This is also a form of equation of a straight line. Okay. So this is what I'm talking about basically. This is what I'm talking about basically. A form of an equation for a given circle, a form of an equation for a given circle. What does that mean basically? It means that we have a form of equation. We have a form of equation for a circle. As I have already told you that the algebraic equation for a circle can be different. So It means that we can write different type of equation. We can write different equation for a given, in different form of equation for a given circle. And this is basically one of them. This h minus x minus h whole squared plus y minus k whole squared is equals to r squared. So this is one of the equations, one of the form of equation. So what does that mean? What does that mean? It means that this equation x minus h, x minus h, y minus k, x minus h whole squared plus y minus k whole squared is equals to r squared is very useful in that case when we really want to know the center of a circle in a convenient way. In simple terms, in simple terms, these equation, this particular equation, this very equation, x minus h, y minus k whole squared equals r squared, is such type of equation which will help you to let you know the center of the circle very easily. Center of the circle very easily. For an example, for this given equation, if you plot it on a graph paper, the circle will look like this, the circle will look like this, the object, the graph will look like this. Okay, so x minus h whole squared plus y minus k whole squared equals r squared. If you plot this equation, on a graph paper, then the geometrical object will look like this. And you must remember that h, k, and r are definitely constant values, or it means that they have numerical values. It has numerical values. H, k, r are numbers. Okay, these are numbers. These are numbers. Definitely, these are numbers. Yes, these are constant for a given equation. They have value. They have value. They have numerical value. They have numerical value. So otherwise, these will be nothing but just a combination of variables. You cannot just plot a combination of variables in a graph paper. You cannot plot a combination of variables on a graph paper, because then the situation will arise like you have variable x, you have variable y, you have variable h, you have variable k, and you have variable r. OMG, that's not possible, man. That's not possible, because five variables will need such a space, such a space that will consist of five axes, five axes. That is basically, that is gonna be Einstein's relativity equations, because a special theory of relativity also consisted of four axes. Okay, but we have five axes. So mind your equation. Okay, I remember. Just this is a basic sense. This is a common sense. This is a common sense, because uh, an equation, we have five different variables: x, y, h, k, and r. If you want to plot that, then you will need such a space, such a reference structure, reference frame, which has five axes. As we are plotting on a graph paper, a graph paper looks like this, and we have y-axis like this, and we have x-axis like this. This is x-axis, this is the y-axis. So we have two variables. Okay, we have two variables, and this is two-dimensional, 2D. This is two-dimensional. And that's why we have two variables. For an example, just consider a situation where we have three variables. We have three variables, and then it will produce a three-dimensional space, and that will look like this. This is the x-axis, this is the y-axis, and this is the z-axis. Do you get it? So this is three-dimensional. Because we have three variables. So if this equation has five different variables, then it will become 5-dimensional equation, but it's not possible. It's wrong. It's wrong. So remember that this H, K, and R are just nothing but numerical values. Just nothing but numerical values. Just like we have like this equation, x minus 2 whole squared plus y minus 5 whole squared equals 81. This 2, this 5, and this 81, they all are numerical values and they carry. This is basically 8, this is H, this is K, and this is R squared. Do you understand?
Yeah.
These are nothing but some numerical values. Please, question. Please do your question.
Yeah.
Do you have
No,
any
it's okay.
question?
No,
Do you have any question?
no.
Okay, so this is gonna be our H and K. This is the center for the form of equation like this. For the form of equation like this, form of equation like for the form of equation like x minus h whole squared plus y minus k whole squared equals r. The center, the center, the center of circle, the center of the circle is equals to h comma k, and the radius, and the radius, and the radius of the circle is equals to r, and the radius of the circle is equals to r. Do you got it?
Yeah.
This is the law. This is the equation. This is the equation. This is the equation, and this is the law. This is it's actually it's not a law. Basically, you can derive everything. You can just derive everything from any kind of mathematical equation. Definitely, you can just derive. And I'm just telling you for your convenience, so that you can just save some time. Okay, you can prove that you can find that this h and k are the center of this circle, and the r is the radius. You can prove that. You can find it, and definitely I can give you the proof. But for your convenience and to save time and energy, you can just memorize it. The h and k is the circle and the r is the radius. Okay,
Mm-hmm.
and don't mess with and then please don't mess with the with the sign, because this is minus h and this is
Okay.
minus k. Okay.
Okay.
For an example, just telling for your convenience, x minus 5 whole squared plus y minus 9 y plus 9 whole squared is equals to 25. Okay, 25.
Mm-hmm.
If this is an equation of a circle, then the value of h comma k would be that would be 5 comma negative 9, 5 comma negative 9. Do you understand?
Mm-hmm.
This is gonna be 5 comma negative 9. And don't mess up with the symbol, because this is just like the equation that we dealt with in the parabola. Do you remember the parabola equation? Do you remember the parabola equation? Because
Mm-hmm.
we dealt in the plus 4 to
Wait.
advanced math
Yeah.
chapter.
I might have written it somewhere.
You read it, right?
I think so. Yeah.
Yes, you read it, because I told you about the symbol. I told you about the sign. That's pretty sensitive, because don't mess up with the same. Don't mess up with the same sign. Don't mess up with the sign, because you just need to, whatever it is, you just need to you just need to make it look like in this form. Maybe we can talk about this. For an example, for an example, um, okay, let me. Here's something. Okay, fine. Now, what is the radius of a circle with equation x minus 2 plus y minus x minus 2 whole squared plus y minus 5 whole squared equals 81? I told you that you just always need to relate. You just always need to relate. You always need to relate with the standard, with the standard form of equation, standard form of equation with the given one. With the given one. And what does that mean? What does that mean? It means that the standard form of equation is this. The standard form of this equation is this: x minus h whole squared plus y minus k whole squared equals r squared. This is the standard equation. And this is the given equation, okay? This is the realistic equation. You just need to compare them. Compare them. And make it look like the standard form. The standard form. The standard form. So what does that mean? What does that mean? It means that this 5 has a positive sign and this 2 has a negative sign.
Wait,
But
wouldn't the 5 have a negative sign?
yes, and that is why we need to make the manipulation.
Oh.
We need to do the manipulation so that it might look like the standard equation. We just need to somehow make it look like negative, but actually it won't be negative. But we just need to give a fake, just like a muse, okay? Just like a muse, okay? Just like the actor and actresses use the muse, and you just need to use the same kind of faking, some fake fakes. For an example, what does that really mean? It means that let's find some empty space here, okay? Let's find some empty space here. Okay. It means that you can make it look like the standard equation. This very equation look like the standard equation if you just write it like x minus 2 whole squared plus y minus 5 curly braces close whole squared is equals to 9 squared. Do we look like this standard form? Do we? X
Yeah.
minus h whole squared
Yeah.
plus y minus k whole squared equals r squared. Do you look like the standard equation form?
Yeah.
What I've just done here. Here we have y plus 5. Y plus 5. You can write y plus 5 equal to y minus 5. Don't you?
Yeah.
Can't you?
Yeah.
Definitely. You can write the y plus 5 equals y negative 5. I'm sorry for the Carly. I'm sorry for the square sign. I'm sorry. This is basically, I'm sorry. This is gonna be y minus 5. So this is it. We can just like relate here. This x is going to be x. This h is gonna be 2. This y is gonna be y, and this k is gonna be negative 5. So how now if we want to find the h and k, then we know for this standard equation, the center is h comma k. The center is h comma k. So now for this realistic given equation, what do we have? The h comma k, the value of h comma k is gonna be 2. The value of h comma k is gonna be 2 comma negative 5. 2 comma negative 5, because we also have negative here. 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 We really don't give a concentration what this 2 looks like or this negative 5 looks like, because we already have somehow managed the negative sign, and we have already somehow managed the negative sign. Do you understand?
Mm-hmm.
You just need to do some. You just need to solve some basically problems. If you manage to solve some problems, then definitely you will understand this very easily. Solve some problems. Solve some problems. This problem 2, 3. Yeah, we will talk about that. What is the center of the circle with the equation? The same approach. They're just manipulating, and they're just somehow finding out the h comma k value. The h comma k value, okay. They're just finding some of the h comma k value, and this is it. As simple as that. As simple as that. Okay.
Mm-hmm.
Any questions?
No, not yet.
Practice. Practice. You cannot just do anything without practice. Practice, make notes, practice, make notes, practice, make notes, practice and make notes. It's a continuous process. It's a continuous process, just like it's a it's a cycle. It's a cycle. It's like a cycle, like making notes, practice, and then learn. Practice, learn, make notes, practice, learn, like this. This is a loop. Maybe you can just learn something new after doing a practice. After doing some practice, you will learn something new. And after doing some practice, when you are learning something new, then you just
Mm-hmm.
need to make it into your notes. Because if you're not making notes, you are gonna forget. You are gonna forget. And that is the most, what should I say basically? That is very disappointing for human being. Because if they are not gonna forget anything, then life could have been far easier if they are not gonna forget. So making notes are necessary, because if you forget, then how do you recall? How do you recall that process of the process of recall, the process of remembering, the process of just like Hansel and Gretel. They just used to they just used to use some stones, just like to find out the navigate the way they remember in a forest. Okay, the story of Hansel and Gretel. So making notes is just like the same thing. You just need to you just need to make notes so that you cannot just recall. You can just somehow manage to recall the way that how you understand that particular topic, or what things do you really need to study, and etc etc. Okay, so radians, we're going to talk about radians. Radian is basically one of the type of units for measuring angles, because I've already told you so many lectures ago that we
Mm-hmm.
have we have the units like degrees, and we have the units like radians, and this is it. And this is we are going to talk about radians, because a radian is a type of way, a type of unit of measuring angles. We are interested to measure an angle, and we can use the radian unit. And what is radian unit invented from? A radian unit, for your conveniences, I'm just telling you that radian unit is this. I'm sorry, radian unit is invented from from circle. So radian value is the value that you can just relate it with numbers, some traditional numbers. What does traditional numbers and regular numbers mean? So for an example, you can convert by from radians to degrees by using this formula. Radians divided by pi is equals to degrees divided by 180 degree. You just need to plug in the values for the radians, whatever. Maybe it is just 3 pi. 3 pi. What is the value of 3 pi in terms of degree? Just for an example, what is the value of 3 pi in radians? 3 pi in radians, 3 pi in radians in degree. What is the value of 3 pi radians in degree? Then how do you solve that problem? 3 pi divided by pi is equals to degree. We are denoting degree as d by d divided by 180 degree. So pi and pi becomes cancelled, and then 380 degree, I'm sorry, 3 into 180 degree is equals to d. So this is going to be the answer. Maybe it is 560, right? Maybe, maybe 560. I forgot basically. I forgot the multiplication. Maybe let's check it out. Figure out 183. I'm sorry, 540. This is gonna be 540. Okay. So
Mhm.
this is how you convert between radians and degrees. This is how you convert between radians and degrees. This is how you convert between radians and degrees by using this formula. By using this formula. Okay. By using this formula, you can just convert from degrees to radians. But the thing that I was going to tell you that is, for an example, maybe it's important for you. Sine 45 degree, it has a meaning, and sine 45 radian, it also has a meaning. Be careful, be careful,
Mhm.
because whenever you're just putting the value, you're just giving an input. You're giving the input of trig function, input of trig function, input of trig function, units of angle. This can be degree, and this can be also in radian.
Mhm.
That means, for an example, sine is a trigonometric function, and you can give the input of a sine function just like this, degree, in terms of degree, in the units of degree. And you can also give the input for a trigonometric function in terms of degree, and you define you just denote this radian symbol by this small c over the head, small c over the head. This small zero is denoting degree. This is denoting degree symbol. This is degree symbol, and this small c is denoting radian symbol. It's denoting radian symbol. Sine 45 radian has a value different than the sine 45 degree. It
Mhm.
has different values. So be careful. Be careful then what they are talking about. Are they taking the value in the radian angle or the degree angle? Are they talking about radian angle or degree angle? And remember, all of our values that we regularly deal with, number one, for example, number 1, 2, 3, 45, 98.6, 98.6, these all are radian values. These all are radian values. These all are radian values. And you cannot, I think these are going over your head. I think these things are really going over your head. But you just need to, please don't skip, okay? At
Mhm.
least try to understand. At least try to understand. You can just do some Google or etc. or whatever it is. Maybe you, if you were interested with this. So radian values are the values that is completely tantamount, completely tantamount to our regular dealing things. What does that mean? It means that radian values are the values that you can just use without any kind of conversion. No conversion needed. No conversion needed. For radian, you don't need any conversion. No conversion. No conversion is needed. No conversion is needed. For radian, you don't need any conversion. You don't need any conversion. But for the degree, if you want to compare it with the values like numerical values, then you need to convert it to radian. You need to convert it to radian, and then you can just compare the radian value with the normal numerical value. Do you understand?
Yeah.
At least if you don't understand, you can just at least take it inside your head what I'm just talking about, because
Mhm.
I'm just talking about that there are two types of degree, two types of units for angle. We have two types of units for angle. We have degrees, we have radians. We have degrees and we have radians. And radian units are coming from circle. Basically, we can relate it to from the circle, because it is coming from circle, and we can convert from degrees to radian by using this formula. We can convert degrees and radians from this using this formula. And they're saying that pi by 2 radians is equals to 90 degree. Pi by 2 radians equals to 90 degree. This book is not using this small c to denote radian, small c symbol for denoting radian, but you can also use this. Maybe some of the books use that. I already told you in so many lectures ago, but maybe you just forgot that. And we can do some conversions. They're just giving us this graph. You don't need to understand, at least like this in this moment. We can talk about that later. But for your kind information, if y I, for your information purpose, for any kind of angle input, you can give the input in degree and in radian. And the most important thing we will deal, that is the input of trig function, in the unit of angle, the input of trig function for the angle. We can input the, we can put the input for trig function in the unit of degree and in the unit of radian. We can put the values in degree, and we can put the values in radian. For an example, we are talking about sine 45 degree, and we are also talking about sine 45 radian. This is an extremely large number. If you want to calculate, just give me a moment. How does that look like? I'm opening my calculator. Okay. So the sine 45 degree value is the sine 45 degree, okay, write it here. The sine 45 degree is valued, I'm using my calculator, that is 1 over root 2. But the sine 45 radian, give me a moment. Sine 45 radian, that is gonna be the value of 0.851 approximately. And if we want to calculate that 1 over root 2, 1 divided by root 2, that is, if this basically the value is close enough to 0.707, but this is 0.851 and this is 0.707. Do you understand what I'm talking about?
So
be careful.
You can use the calculator in the SAT.
Sorry?
You can use the calculator in the SAT.
These things will not be asked in your SAT. Never ever. I'm just giving you for your kind information. But you just need to at least remember. That the input of a trig function or whatever angle, for any kind of angle, we have two different units. We have radian and we have degrees. And for a trigonometric function, we can give the input in degree or in radian. And you need to be very careful. And you just need to understand. You just need to try to understand in that at least it is mentioned, it will be mentioned absurdly or directly, that what type of unit of angle they are dealing. What type of unit of angle they are dealing. The unit of angle. Unit of angle they are dealing with. It's very important. If it is complicated math will not be asked at SAT. That is 100% sure. But you just need to know, at least for your kind information, that the trigonometric function can have the input in degree unit and in radian unit, and the values will be different. I'm just giving you an example for 45 degree and 45 radian.
Yeah.
Just making you understand that this number 45 looks similar, but they're having different values, different outputs. Because why? Because this is the radian unit and this is the degree unit. Be careful. Be careful. Maybe you won't face ever something like this at SAT, but for your kind information, whatever. So now we have some practice problems. These are some pretty easy problems, and you are suggested to solve at your home, at your home. So do yourself, do yourself, do yourself, and you can solve it. And you need to use your brain, definitely. I'm going to talk about a problem that is basically this problem, and this problem number 7, which is very important for the SAT, which is very important, which is quite important for the SAT. This is a they're just telling that we have given an equation. We have given an equation like this, equation like this, okay? And we are asked radius. What is the radius? What is the radius? Our question is, what is the radius? Okay, so Mr. Radius, Mr. Radius is our point of interest. Mr. Radius is our point of interest. You just need to find the value of radius. What is the value of radius? What is the value of radius? And how do you find the value of radius? Just give me a clue at least. I'm asking you, give me a clue. How can we find the radius?
Set it up in standard equation.
Standard equation, okay, but does this, thanks for telling this, at least one clue. Does this thing look like the standard equation? I mean, this equation, does this equation look like the standard equation?
Oh no, but like the radius equation.
The radius equation, the radius equation. Okay, then how do you then how
Or
do
you
you
could
what can I do? What can we do? What can we do? What can we do? What can we do?
maybe combine like terms.
We have this equation and we just need
Yeah.
to make it look like the standard equation. Then what can we do?
I'm not sure.
We just need to do some algebraic manipulation. Algebraic manipulation. We need to do some algebraic manipulation. We need to do some algebraic manipulation. And what does the algebraic manipulation mean or look like? This is also an algebraic manipulation. This thing that we have done here. This is also an algebraic manipulation. Do you remember that we just made this equation look like this +5 make look like -5?
Yeah.
This is an algebraic manipulation. Nothing is changed, but we are just trying to look it like similar.
Yeah.
We are just trying to give it a face, kind of a similar face, and that is where we're just gonna do here same. We're just gonna do some algebraic manipulation. We're just gonna do some algebraic manipulation, and then we're just gonna make it look like similar. Okay, we're just gonna make it look like similar. And how to make it look like similar? How to make it look like similar? We're just gonna do some algebraic manipulation, and so we're just gonna do such kind of steps that will make these equation look like this form: x minus h whole squared plus y minus k whole squared equals r squared. And to do that, we need to do the algebraic manipulation. We need to do the algebraic manipulation on which equation? We need to do this algebraic manipulation on this equation to get this type of equation. We need to do algebraic manipulation over this equation. Over this equation, we need to do the algebraic manipulation to get this form of equation, And how to do that? How to do that? You can just make something look like the basically we have the x term and y term here. there's basically single here, and you just need to make the x term look like a whole squared term and the y as a whole squared term, and then you can just do it. For an example, x squared minus 4x plus y squared plus 2y equals 11. Okay,
Mm-hmm.
so you just need to look it like x minus something whole squared plus y minus something whole squared equals something dot 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 dot, and you just need to balance with the numbers, this number. Do you understand?
Mm-hmm.
For an example, x minus 4x plus a squared minus 2ab plus b squared, right? So
Mm-hmm.
if you just break it, then the thing will look like x squared minus 2 into x into 2 plus 2 squared. Then it becomes a whole square, a complete square, right? And
Mm-hmm.
this is nothing but x minus 2 whole square, right? I
Wait.
think this x minus 2 whole square.
Okay.
I repeat, x minus 4x, x squared
Mm-hmm.
minus 4x. If you want to make it look like, if you want to make it look like a squared minus 2ab plus b squared, then you just need to write it like x squared minus 2 into x dot 2 plus, this is not equal, okay? This is not
Mm-hmm.
equal. This is not gonna be equal, but you just need to balance it. You just need to balance it. Okay, how? Okay, how? Okay, how to do that? Okay, I'm gonna do a basically a um and some empty space and some empty space. Okay, how did they do it? They haven't used any kind of explanation here. Okay, let me try to make you understand in a simple terms. Okay, let me try to make you understand in simple terms. Okay, so we are just asked that we need to we need to make this equation we need to make this equation look like this type of equation, and to do that we need to do the algebraic manipulation, and to do the algebraic manipulation we need to like the we need to make the equation look like this x minus something whole squared plus y minus something whole squared equals something squared,
Yeah.
right?
Yeah.
Right, do you understand at least at this point?
Yeah.
Okay, then okay, fine. Then we can proceed. Then we can proceed in some other way. Okay, we can other way
Mm-hmm.
means like we can proceed in terms of algebraic manipulation. What is the radius of the circle with this equation? Um, this equation. So our our approach is we just need to do a we just need to do a thing that will make us this equation, this green boxed equation look like the standard equation, standard equation of circle. And how to do that? To do that, we need to do the algebraic algebraic manipulation of this equation. Okay, okay. So we are interested to make this equation look like the standard equation of circle. And to do that, we need to do the algebraic manipulation of this given equation. And how to do that? And this is the process that is written in this red color. We can do the thing like in this way, in this red green red written lines. So the given equation is x squared minus 4x plus y squared plus twice y equals 11. And we need to look it like x. We need to look it like this. We need to look it like this. And to do this, and to do that, and to do that, we are just gonna make some packet. We are just making a packet of x, and we are making a packet of y. We are making a packet of x, we are making a packet of y, and the constant numerical value is kept in the right side of this equation. And this packet can be written like this. This packet x minus 4, x squared minus 4 can be written like this: x squared minus 2x into 2. X squared, this 4x can be written like this: 2x into 2. And then we are adding an extra term. We are adding an extra term, 2 squared. And why we are writing this 2 squared? Because we are interested to make it look like a squared minus 2ab plus b squared. But here a squared minus 2ab is already given, but we don't have a b squared term here. So that's why we're adding an extra b squared term so that we can make it look like a squared minus 2ab plus b squared. Do you understand?
Yes.
Okay, I'm telling you again. Okay, I'm telling you again. Basically, x squared minus 4x. We have x squared minus 4x, right? Because this is the very first line of this equation. This is the very first line of this equation, and this is the very first line of this equation. And we're just making a packet of x and making a packet of y. This is a packet of x, and this is a packet of y. This is a packet of x. This is a packet of x. OMG, I'm sorry. OMG, sorry. This is a packet. This is a packet of x.
Yeah.
And this is a packet of y. The 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 packet of y. And this is the packet of x. 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 And the packet. And we're just making packet. We're making a packet of x and we're making a packet of y. And this x packet and this y packet, we want to look it like a minus b whole squared. We want it to make look like a minus b whole squared or a plus b whole squared.
I have a question.
Okay, sure.
Yeah, is there an easier way to do this? Because I think that, like, I'm not sure.
So you're just asking, is this the only way to do this?
Yeah.
I think this is the only way to do it. And I'm just giving you a detailed explanation, but the solution doesn't have any kind of detailed explanation like this. They're just, they're just doing this way. But they're doing the same that I'm telling you, but I'm just giving you the detailed explanation because they're skipping so many lines. Okay, sure.
I'm not getting with the A, B, and A, like the AX, AB, all that. Where's that coming from? I don't get that.
Oh, you don't understand how these A and B terms are coming from.
Yeah,
okay, it's okay, but have you ever read that if there is a basic, the most basic formula we have, that is a minus b whole square.
No.
That is a plus b whole squared.
Yeah.
And a minus b whole squared. Do you know the formula?
No, I think this is my first time seeing this.
You know this.
Yeah,
you know this formula. You know this formula, right?
Yeah, a little bit, but I never really went in depth. So
sorry?
I never went in depth with this formula, so I don't have much practice with it.
Okay, it's okay. You don't have any practice with them. But the thing is, we want to apply these equation, these two formula here.
Yeah.
Because
yeah.
And our main target is to look it like a minus b whole squared or a plus b whole squared, because we want to make it look like this x packet and this y packet either a minus b whole squared or a plus b whole squared. Which one is suitable, we will apply that. If it is negative here, minus 2x into 2, if it is negative, then we are going to apply the a minus b whole squared. And if it is plus, and then we are going to apply a plus b whole squared, this plus
But
term.
where's like if you're putting it in the XY formula, what's A and what's B?
No, you are not just putting it in the a or b. You are not just okay, all right. Can you please write x plus y whole squared? X squared plus 2xy plus y squared.
Oh, okay.
X minus y whole squared is equals to x squared minus 2xy plus y squared.
Mm.
The a and b is gonna be, the a is gonna be the x, the b is gonna be the 2 here for the a minus b whole squared.
Yeah.
The a and b is can behold any kind of value. The a and b can behold any kind of value.
Mm.
The a and b can behold any kind of value, but the thing is, point is, but the point of concern is, we just need to make it a whole square. This is a whole square. This is a whole square term. 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 And we need to make it look like the whole square term. And how to do it? The only way to do it is you just need to add some extra constant here in this x packet, and you just need to add an extra term, add an extra number with this y packet.
Mm-hmm.
And as you are adding some extra value, as you are adding some extra number here, you also need to subtract. You also need to subtract so that it might keep the balance. It might keep the balance because you are adding forcefully. You are adding. You are just forcefully adding 2 squared, and you are just adding 1 squared forcefully, and you just need to subtract it to keep the balance. But you are adding it to make the whole square, right?
Mm-hmm.
Man, just look at this equation. Just look at this calculation. You just don't need to make it too much complicated. Just look at this because we are just doing separation. We are just making the x term separated and the y term separated. And that's why we're using the parenthesis. So we're just making x packet and we're making y packet. And this x packet, we are trying to make it look like a whole square term. And to do a whole square term, we are just we're just grinding it. We're just breaking it into a plus b whole squared formula. We're just breaking it into the a minus b whole squared formula. X squared minus 2 into x into 2 plus 2 squared. There is no 2 squared here. There is no 2 squared here. But we are adding an extra 2 squared here just to make it look like whole squared. Do you understand it right now?
Yeah. Kind
The same thing you will understand eventually if you are practicing. You will
of. Mm-hmm.
use pen and paper. Use pen and paper. You have watched enough videos. It's time to grab it's time to grab your pen and paper, man. Please.
Mm-hmm.
It's time to write down math equations on paper by some solid, real, touchable paper. Notebook. Buy some notebook from a grocery store or whatever it is. Okay, fine. Then we are adding 2 squared here, we are adding 1 squared here. To keep the balance, we are also subtracting 2 squared and we are also subtracting 1 squared, right?
Mm-hmm.
From the laws of equation, you are just keeping it as it is. You are just keeping it as it is, but you are just taking this 2 squared and 1 squared on the right side. And by taking it to the right side, it will change its sign, right? The 2 squared will become positive and the 1 squared will become negative. 1 squared will become positive 1 squared, right?
Mm-hmm.
Okay, then do the simple calculation. 11 plus 4, 11 plus 4 plus 1, that is 16, right?
Mm-hmm. Yeah.
And you can just write 16 is equals to 4 squared. 16 is equals to 4 squared, and that is what is happening. And then you just can you just can you can just write this x term into this full whole square term. This is basically nothing but x minus 2 whole squared. Okay, okay, all right, okay, all right, okay, all right. Empty space. X minus 2 whole squared. How to solve it?
Mm. Does that
This
say
is
negative 2 times pi times 2?
5
Wait,
times. How?
wait, no, what does it say? I can't read that. Like what you just wrote.
Can you say this right? I'm just watch it again.
Okay.
X minus 2
Yeah,
whole squared is equals
yeah,
to x squared minus 2 multiplied by x multiplied by 2 plus 2 squared.
okay,
And it becomes x squared minus 4x plus 4.
okay.
So if you are asked, if I ask that x squared minus 4x plus 4 is a expression, you need to make it look like a minus b whole squared expression. Then how do you do it?
Are you asking?
I'm asking you, I'm asking you,
Yeah,
I'm asking you that you are given x squared minus 4x
yeah,
plus 4
yeah.
is a is an algebraic expression. You need to make it look like a minus b whole squared form. Then how do you do it?
You go back and you change it to like the
Tell me what should I write?
negative, you change the minus 4 to um 2 and negative 2.
Exactly.
And,
You do
yeah,
the back calculation. You do
yeah,
the back calculation.
yeah.
Here we have just go like from the upwards to the
The
downwards.
other way, yeah.
And in this way, in this thing, we just need to go from the downwards to the upwards.
Mm.
From the downwards to the upwards, right? The back calculation, back calculation, back calculation. You just do some back calculation. And this is what we are doing here. This is what we are doing here. We can just write this x minus 2 whole square term from this doing this back calculation. This is a simple formula. This is the most simple formula. Just ask a
Mhm.
baby who is just newly born, maybe who is just 5 days old, and ask that baby what is the equation of a plus b whole squared. A 5 days old baby, he will give you the answer that a plus b whole squared equals a squared plus 2a plus b squared. Literally, literally, because this is the most fundamental equation in algebra.
Mhm.
You just do some backward calculation. There's no backward and upward and downward calculation. These things are nothing but making it complicated. Use pen and paper. Do this calculation in your own hand. You will automatically understand why we are adding this 2 squared here, 1 squared here, and then we are just balancing, and then we are just making it look like the standard form. This is the question that you are going to be asked at the stat test. Trust me, that these type of questions that we have done earlier in the example, those are not just problems that will you are going to appear in the SAT. These are some just the example problems is nothing but some problem. They are not any kind of are just these are some just pretty simple things. But these type of problems are the problems that you are going to face. So you need to practice and you need to understand, you need to use your brain, what things you need to do. And then what we have done just this curly braces thing to make it look like this standard equation, similar to this standard equation. Because we had x minus 2 whole squared and we kept it the same. We kept it the same as x minus 2 whole squared. But we have y plus 1 whole squared, but we have just changed, we have just done some uh, pretty little, pretty little manipulation. We have just made it look like y minus 1 whole squared equals 4 squared, so that it might look like y minus k whole squared. Okay, so here the k is -1, the k is -1, and here is the h is equals to 2. Okay,
Mhm.
so you can just write from this standard equation x equals 2, k equals -1, and r equals 4. This is gonna appear in the test. Okay, so the last problem of this chapter, the rest is gonna be your homework. So uh the last problem is problem number 9, a real problem. Okay, so
Mhm.
at what point will a circle with the equation and the line intersect? We have just given an equation. We have given an equation that is x minus 4 whole squared plus y minus 5 whole squared is equals to 9. We have given this equation. And now we have also given a line that is y minus 2, y equals -2 intersect. We're just asked in at what point these two geometrical shapes or geometrical entities will intersect. And the simplest and the most basic and the most fundamental concept to solve this problem is just nothing but solving these two equations. Just solving these two equations. And how to do that? To do this problem, you can just simply plug in the value of y equals -2. Y equals -2. You can just plug in the value of y equals -2 into this equation. You just plug the value of y equals -2. And then solve for x. X equals what? Solve for x equals what? Okay?
Mhm.
That is what we're doing. That is what we are doing. We have just plugged the value y equals -2, y equals
Mhm.
-2 here in this equation. And then we have solved x minus 4 whole squared, x minus 4 whole squared plus y minus k whole squared. So we have just plugged the value of y equals -2. This y equals -2, y equals -2. We have done some simple calculations, x minus 4 whole squared plus 49. This negative negative 7 whole squared becomes 49 plus 49 plus 9 equals 9. And then x minus 4 whole squared is equals to, if you just take this 49 in the right side of this equation, this becomes -49. And after doing this, we get -40. Okay. And then x minus 4 is equals to, becomes, as this is a square term, if you want to calculate the value of x minus 4, definitely there will be a root assisted with this term. And the most important thing is, you just cannot do any kind of negative number root without introducing the imaginary number. without introducing the imaginary number. Without introducing the imaginary number. And what does that mean? It means that it means that it means that you are just gonna do this problem as x minus 4 is equals to plus minus negative 40, negative root over 40. This is basically something which is appearing a negative number inside the root. A negative number inside the root. A negative number inside the root. This is gonna produce an imaginary number. An imaginary number, because we can solve the root for any positive number. Any positive number. Any positive number. For example, the root of 16 is equals to 4.
Yeah.
The root of 25 is equals to 5. The root of 49 is equals to 7. But what if negative 16? What if negative 25? What if negative 49? What if? This is basically some imaginary number problems. You need to use the imaginary number I, to solve this problem. But I'm not going to interested to discuss much about that. What I'm really trying to tell you that is, as you have just plugged the value of y equals negative 2 here in this equation, you have plugged the value, y equals 2, you have plugged the value y equals 2, you have plugged the value of y equals negative 2, y equals negative 2 here in this equation, you have plugged the value y equals negative 2 here in this equation, and after solving this equation, putting as y equals negative 2, we are getting that x equals something like this, which has a term, a negative number under the hood of root. So it's an imaginary number. And an imaginary number doesn't have any kind of intersection. And that's why they will not intersect. Because the value of x is imaginary or complex. Actually, it's a complex number. X is here a complex number. So that's why x has a complex number, and y has a real number, So it will never ever intersect each other in the real plane. Sorry for the complicated words. Real plane, you don't need to understand what is actually a real plane. So they will not intersect each other, okay? They will not intersect each other because the values of x is appearing as complex. So that's why they will not intersect. And if you can draw, then you can draw some graph paper. You can use some graph paper, and then you can just plot it, and then you can just draw this y equals negative 2 line, and then after drawing and wasting a lot of time, you can say that they will not intersect. But if you at least do these simple lines, if you're good at this calculation, then you just don't need to waste such a lot of time, and you can just easily say that they will not intersect. Do you got me? Waste your time or be smart. The choice is yours. That's all for today. So just for a brief summary, what we have studied today, we have talked about circles, we have talked about radius, we have talked about the area, we have talked about circumference, so we have talked about the angle, we have talked about radius and diameter, the difference between radius and the diameter, and the relationship between radius and diameter, the area and circumference formula for a circle in terms of radius, and the area and circumference formula for a circle in terms of diameter. We have talked about the circumference. We have talked about the area. We have solved the problem. We have solved the example. We have come to know about 360 degree of a circle, 360 degree in a circle, full rotation. We have talked about inscribed angle. We have talked about inscribed angle. We have solved an example. Same arc, inscribed angle, central angle, formula, theorem. And then we have talked about arc length. And then we have talked about sector area. And then we have come to know about a problem that is extremely important, but the solution can be done in a pretty simple short way. Circle formula is required in a geometric concept of circle, which is basically our field of interest, x minus h whole squared plus y minus k whole squared equals r squared. Analytical geometrical concept we're relating here. The h and k here is the center, so the 3 and 2 is here is the center. So the 3 and 2 here is the center, and the 4 is the radius. The 4 is the radius. The 3 and 2 here, the purple colored shaded here, this 3 and 2 is the center, and this 4 unit is the radius. And we have done some problem. We have done some problem plotting and then finding the radius, finding the center, finding the equation of a circle in the coordinate plane, in the real plane, analytical geometrical problems, and then radians. We have understood the concept of radians. 180 degree equals pi radian. We have come to know about that, and we have already understand a conversion formula for radians and degrees, the types of units for types of units of angles, which is basically nothing but the degrees and radians, common units. You can skip that. You can skip that at least for your SAT. Skip that. And input of trigonometric functions, degree and radian, and we have done some trigonometric, and we have done some real problems, some important real problems. That is basically manipulation of equation, and then transferring the formation into a standard equation of circle. And we have already talked about the intersection of a circle and a line. And we have also some real problems, and those are suggested. Those are suggested for your homework. You just need to do it. You just need to solve the problems for as your homework. So that's all for today. That's all for the chapter additional topics in mathematics. That is circles. Thank you. Thank you so much. Thanks a lot.